This student book belongs to a set of student books which altogether provide a complete set of information to master SDMX. This student book aims at providing an introduction to the SDMX information model, statistical data and metadata, the basics of the SDMX information model, and the objects of the SDMX information model. Let's start with a simple example. A member state wants to send Eurostat a statistical table on tourism accompanied by corresponding methodological notes. For the purpose of this exchange, the following information should be collected. Statistical data corresponding to the datasets. They can be organized in time series or be cross-sectional. Statistical metadata are divided in structural metadata, describing the structure of the table, and reference metadata, in our example, the methodological notes. Let's first consider the two different representations of the statistical data. This table shows statistical data of the tourism sector in a time series organization. The series in the first column contains the time dimension representing the annual series of observations for one country, for example, Italy. This table shows statistical data of the tourism sector in a cross-sectional data organization. The time is fixed to the year 2007 for annual data. The section in the first column contains the cross-sectional measures, AT for Austria to IT for Italy. Let's imagine we have to describe our table for tourism statistics in a standard way. Take a simplified table, 3 tourism topics over 4 periods. What does SDMX need for describing a statistical table? First of all, we need to identify a set of statistical concepts. We can identify the following statistical concepts: frequency, in this case annual, country, tourism indicator, tourism activity, time period, the observation value, which is the actual single figure, the observation status, defined by footnotes such as estimated or provisional, the unit, identical for all the figures. To summarize, frequency, time period, country, tourism indicator, and tourism activity are required to identify the statistics. They act as dimensions. The observation value, the actual figure, is what we call measure. The observation status and unit further explain the figures as an attribute. We can see that they are displayed at different levels of the table. This depends on whether the attribute explains only a single figure, a group of figures, or the whole table. In our example, the unit explains the whole table. It is attached at dataset level. The observation status explains only single figures. It is attached at observation level. In SDMX, it is also possible to attach attributes to a group of observations. This is not the case in our example. The result of our small exercise is a formal definition of the corresponding data structure. Of course, apart from the structure, we need to know how the concepts need to be coded in the data exchange. To finish the data structure definition, also called DSD, with all the structural metadata of the table, we need to look into code lists. In the SDMX information model, concepts act as identifiers and descriptors of the data. A concept consists of an identifier reference area, a name, and a description. Names and descriptions can be stored in multiple languages. A code list is a set of values to be used in the representation of a concept, dimension or attribute in data and metadata structure definitions. Examples are the code lists country and code list of tourism activity. Each code is defined uniquely by a value and a description that can be provided in several languages. Partial code lists can also be exchanged. The content of the partial code list is specified on a constraint. This makes it possible to use common, and often quite large, code lists in multiple DSDs and then to restrict their content to a subset for use in a specific DSD. In our example, the list of countries is limited to 4 codes. To ensure maximum interoperability in the exchanges of statistical data and metadata, the SDMX standard includes content-oriented guidelines and a standard XML format. For harmonization, the standard comprises a set of recommendations for the use of cross-domain concepts and code lists. As we have just seen, data structure definitions are formed by 3 sets of concepts in the information model. The dimensions, comprising the time dimension and the keys as time series or cross-section key and optionally group keys. The series or section keys are dimensions whose combined values in a dataset uniquely identify the observed data series or section. Group keys represent subsets of the time series or cross-section keys. They define groups of series or sections to which attributes can be attached. The list of attributes, where each attribute must be assigned an attribute relationship. This identifies the structural constructs that could trigger a change in the value of the data attribute if the value of that structural construct changes. This can be either a dataset, a single or a group of dimensions, or an observation. The list of measures, comprising 1 or more measures. The primary measure is used in time series data presentation. For the cross-sectional data organization, a specific measure dimension may contain multiple cross-sectional measures. Concepts are gathered in concept schemes. Concepts can be represented by numeric or textual values or by codes from defined code lists. The data structure definition being defined, let's see how the statistical data are organized in the file to be exchanged, what is called dataset in SDMX. In the related SDMXML structure-specific time series data file, we can highlight the different structural constructs to which attributes can be related. The dataset, where for this example attribute unit is related, the series, where for this example no attribute is related, and finally the observation level, where the attribute observation status is linked to. Each information in the table is placed into the dataset with its corresponding concept name: unit, frequency, country, tourism indicator, tourism activity, time, observation value, and observation status. We have seen from the previous example how data are structured into a dataset. The following diagram shows how it is modelized into the SDMX information model. Datasets are composed of a number of time series or sections, the cross-sectional organization of observations at a single point in time. An array of values of the dimensions as key elements identify the particular time series or cross-section. Thus, those keys are also referred to as series key for time series data or section key for cross-sectional data. In the case of the group key, a particular group is identified containing a group of the data series or data sections where attributes can be attached to. The related group key contains a subset of the dimensions of the series key or respectively the section key. Further elements are the observation value and the time period for time series. Attributes provide additional information and may be attached to the following structural constructions by using the attribute relationship mechanism: the entire dataset, the group key, the series or section key, the observation level. To summarize, structural metadata provides the frame to interpret data or reference metadata through descriptor concepts. These concepts act as identifiers and descriptors of data. The concepts can be dimensions, attributes, or measures when they are arranged in a data structure definition to define a data set. Concepts are also the building blocks of a metadata structure definition, acting as attributes defining the structure of a metadata set. We will look into that now. In the SDMX information model, reference metadata provide additional explanations to the data. It may consist of different types of metadata, such as conceptual metadata, describing the concepts used and their practical implementation, methodological metadata, describing methods used for the generation of the data, and quality metadata, describing the different quality aspects of the statistical data. This information is contained into metadata reports structured through specific concepts we will see now. Metadata reports are structured using a set of main concepts. In this example, taken from the Eurostat standard metadata format, these concepts and subconcepts represent the metadata elements for which a text needs to be reported. In the example, contact organization has the value Statistical Office of the European Communities, Eurostat. In the same way as we define the structure of the table in a data structure definition, we also need to describe the structure of the metadata report. In the SDMX information model, this is done with the so-called metadata structure definitions. They comprise the specification of the object types to which metadata can be reported in a metadata set, metadata targets. The metadata structure definition defines also the metadata report structure, comprising the metadata attributes that identify the concept for which metadata may be reported in the metadata set. Metadata attributes take their semantics from concepts maintained in one or more concept schemes. In our example, the metadata report structure comprises metadata attributes that identify the report period target, which is 2010, the category target, which is identified by a reference to the object, the data provider target, which is identified by a reference to the object. In our example, the concept used in the metadata report can be easily retrieved into the metadata set. Attribute contact, with its three subconcepts, organization, organization unit, and address. Attribute metadata update, with its three subconcepts, last certified, last posted, and last updated. A reference metadata set is a set of information regarding almost any object of the statistical data exchange with SDMX. Within a reference metadata set, the metadata target keys identify the statistical data or metadata, which is described by this reference metadata. The description is done by metadata attributes and its reported values. The metadata set generally comprises multiple metadata reports. Each of the reference metadata reports comprises the identification of the particular target object to which object the reference metadata is attached, the reported values of the metadata attributes, which make up the reference metadata report structure. This structure follows the definition of the concepts in the metadata structure definition. Let's go back to our first example. Italy wanted to exchange statistical data and the corresponding methodological notes with Eurostat. What did we achieve so far? We described the statistical data to be exchanged with the concepts and code lists building a DSD, the data sets that need to be exchanged, and the additional notes with the MSD and metadata sets. What is missing is the organizational part. To know which organizations are involved and how often they exchange which data, we also need a set of formal objects to describe the exchange process, expressed by the data and metadata flow and provision agreement. Let's see how these artifacts are used together with our DSDs and MSDs. The SDMX information model consists of formal objects to model statistical data and metadata. The data set or metadata set, which conforms to the rules of a data or metadata flow. The data flow or metadata flow, which applies a specific data or metadata structure for data or metadata from multiple data providers. It can also be linked to categories in multiple category schemes. The data or metadata structure definition, defining the concept's structure for data or metadata. The category, which organizes statistical subjects and can have child categories. The category scheme, gathering categories of statistical subjects. The categorization, categorizing objects in the information model. The data provider, who can provide data or metadata sets for many data or metadata flows according to a provision agreement. The provisioning agreement specifies the content of the data provision. The constraint, which can restrict the data exchange at the data or metadata flow level or the provision agreement level. Categories, gathered in category schemes, provide a way of classifying data for collection, reporting, or publication. A category can categorize any type of identifiable artifact, such as DSD or data flow, by the use of the object categorization. For example, many different DSDs and MSDs were created for the tourism statistical domain. These DSDs can be regrouped in a category called tourism. Constraints is a maintainable artifact that can be associated to one or more of the following elements: data structure definition, metadata structure definition, data flow, metadata flow, provision agreement, data provider, simple or queryable data sources. Attachable constraints. The attachable constraint is used to define cube slices, which identify subsets of data in terms of series keys or dimension values. The purpose of this is to enable metadata to be attached to the constraint and thereby to the cube slices defined in the constraint. The metadata can be attached via the reference metadata mechanism, MSD and metadata set, or via a group in the DSD. Content constraints. Data or metadata providers can apply constraints on the scope of the data or metadata that can be supplied in terms of key ranges or complete key sets. These constraints on the content of a data provision can be specified for a DSD, data flow definition, MSD, metadata flow definition, and a provision agreement. They constrain the use of a corresponding structure definition for a data or metadata set in relation to its data flow definition or provision agreement. In our example, we use the constraint for the country code list to provide only data for 4 countries. Besides the objects described before, the SDMX information model includes detailed technical model definitions and further components, such as structure sets, reporting taxonomy, process and transitions, transformation and expressions. They are all detailed in the SDMX documentation. SDMX is sponsored by 7 international organizations since 2001. If you want to know more about it, look at sdmx.org, which provides the technical standard and guidelines and also links to other resources, such as the SDMX info space and self-learning tutorials on specific topics.